To questions 6, 7, 8, and 9, as well as 10. We've got here, and you should recognize it as a square root x function. Not that that matters at the moment, but it is a square root function. So now we're going to talk about the y-intercept of this function. Of course, that means where the graph touches the y-axis. And of course, since we're talking about where it touches the y-axis, we are using y-values. So here's the y-axis right here. And this graph right here is going to touch there at -4. So that means the coordinate is going to be 0, -4. The domain let me change colors here. Okay, the domain, as we have said before, are the x values on the graph. Okay, that means we're going from left to right. As we look at the left side of this graph, we notice that there's a definite beginning. And since we are talking about x values, we're going to look at the value of this line right here at this point. So we look up, and the x value is going to be 0 at that point. And the rightmost point, if we're going to the right, is an arrow. So that means it's going to keep going forever. Another way to write this is x is going to be greater than or equal to 0. Now we're going to talk about the range. Okay, and we said the range is y values of the graph, which means from bottom to top. All right, so let's look at the way this graph looks. So looking at the very most bottom point here, you see there's a, there's a bottom point right there. And we're talking about y values, so we are able to talk about it starting at -4. And when we go upward here, we notice there is a arrow saying it's going to keep going, and it's going to keep going up too. So that means it's going to go to infinity. And another way of writing that is y is going to be greater than or equal to -4. Number 9 is identifying the intervals of increasing. Okay, so that means what x values make y go up. Okay, so looking at the graph here, we will see that as we travel from left to right, what's happening to the y values, we notice that it's going to be going up. So it's pretty much this whole graph. So we're going to pretty much copy the domain here because this is the entire graph that's going to be increasing. So it's going to start at 0. Remember, it says x values, which is why we're looking at the x value at that point here. So 0 to infinity, or as we said before, x greater than or equal to 0. Number 10 is what we will call end behavior. And what this statement means is this right here, as x approaches infinity, that means as we go to the right, y approaches what? Okay, so as we travel to the right, what's happening to the y values? Okay, and you notice that y values, that means elevation, verticality, okay? So is it going up or down? And in this problem, it's going up. And how do we say going up forever on y, and that is positive infinity? Number 11 says, what makes a function an even function? And that's pretty much just symmetry over the y-axis. An example would be a quadratic function. Could be an absolute value function. But you notice that if I were able to fold this graph, this half here looks exactly the same as this half. This half looks the same as that half. The problem is that if you move the graph somewhere else, it's no longer even, because you can't fold it over the y-axis. Now this doesn't mean even power graph. This is just a plain, purely even graph. What makes a function an odd function? We call it rotational over the origin. Or sometimes we say about the origin. What does this mean? Well, one example of an odd function is an odd power function that is on the origin. Okay? This means that if I took this part here, cut it here, and rotated it over, it would be exactly on top of that part. So if we look at number 12, is it going to have an even description, an odd description, or is it neither of those? And if you notice, if we break it here and took this part right here and rotated it this way, it would look exactly like that. So that means it is an odd function.